Hi fellow mathematicians, you're welcome to John Calculus Math class. So today in this video, we shall be finding the limit of this function, and we are having limit x approaches 0, x minus sine x over x to the power of 3. So you can pause the video if you want to try it yourself. And when you observe, we'll be using our L'Hospital's rule to evaluate this limit. So let's get started. Now, before we continue, remember, anywhere you see your 0, your x, you plug in your 0 there. So we'll be having 0 minus sine 0 all over x, all over 0 to the power of 3. And this is equals to 0, sine 0 is 0, 0 minus 0 is 0. 0 is power of 3 is 0. So when you are finding a limit of a function and you have 0 over 0, just know that you've not arrived to your final answer. And this is called indeterminate form. This is called an indeterminate form. So we just have to apply our L'Hopital's rule. Apply L'Hopital's rule. We apply our L'Hopital's rule, and we have limit x approaches a f of x over g of x, which is equals to limit x approaches a. So we find the derivative is f prime of x and g prime of x. So this means that we'll be finding the derivative of this given function. We'll find the derivative of x minus sine x and the derivative of x to the power of 3. Now I'll bring my limit x approaches 0, so my d over dx, have my x minus d over dx, then my sine x all over d over dx, my x to the power of 3 dx, x to the power of 3. This is equals to, now I'll bring my limit x approaches 0. Now the derivative of x is 1. I put my 1 here. The derivative of sine x is cos x, so I put my minus cos x all over the derivative of x to the power of 3 is 3x squared. So what we need to do, we just have to plug in our 0 into our x, and this will be equals to, let me come to this side, my limit x approaches 0. Remember my 1. When I plug in my 0 into this x, we'll be having cos 0 over 3, 0 to the power of 2. You see, now 1, let me bring my 1. Cos 1 is 1. My 1. 0 is power of 2 is 0. 0 times 3 is 0. And this is equal to 0 over 0. You see, we are still having 0 over 0. So apply our L'Hopital's rule once again by using this to find the derivative of this. And now we'll be having limit x approaches 0, and my 1 minus d over dx cos x all over d over dx 3x to the power of 2. This is equals to, I bring my limit x approaches 0. The derivative of 1 is 0, so I don't have to put it. and the derivative of cos x is minus sine x. And remember, we're having minus here, so it will become positive. So we'll be having sine x all over the derivative of this will be 6x. So we apply our 0 into our x. So we'll be having limit x approaches 0. When plugging our 0 into our sine x, sine 0 is 0, so put my 0. 6 times 0 is 0. You see, we are still having 0 over 0. That means we will still apply our L'Hopital's rule again. That's why we continue to apply till we did not get 0 over 0. You understand? Now we apply our L'Hopital's rule for this. Now let me just come to this side. My limit x approaches 0 and my d. Okay, let me just go straight. The derivative of sine x is cos x. Y derivative of 6x is 6, and this is equals to, when we plug in my 0 into x, cos 0 is 1. Then remember, this is not having any sign, so we'll be having 6. So finally, our answer will be 1 over 6. I hope you really enjoyed this. So thanks for watching. And once again, this is John Calculus Maths Class. Please don't forget to like, comment, and share this video. Thank you.